Okay. So the last topic that we're going to be going over in preparation for the test on Friday, okay, is inverse trig. Well, inverse trig functions, I should say. So, whoop, I'm way zoomed in there. There we go. Okay. An inverse trig function is like every other kind of inverse that we do. It kind of like is working backwards from the kind of normal way or the first way that we learned how to evaluate trigonometric functions, right? So just like you learned how to square something and then you learned like the square root, right? Just like we learned, you know, well, exponential stuff, and then we learned about logarithms, right, to kind of undo that. Now inverse trig functions are going to kind of do the same thing, okay? So in the past, right, we've seen, so like earlier, we did something like this. Sine of, I don't know, let's say pi over 6, okay, is equal to, and then we had to fill in a blank, right? We're like, okay, what is the sine of pi over 6? That's what we were trying to evaluate here. So in other words, we were given an input for sine, right? And we were said, okay, so sine evaluated at that radian measure pi over 6, what is the ratio? So the input was a radian measure or an angle, right? And the output, our answer, what we were looking for, was going to be some ratio, okay? And what is sine of pi over 6? Yes, it is root 3 over 2 or 1/2, but which one is it? It's 1/2. Okay, it is 1/2, yes. Okay. And there will be questions like this on your test. It won't be timed in that I'm not going to like, you know, give you a short time. It'll be the class period, of course. But you still would need to be able to do this kind of stuff without a calculator. Okay, so make sure you're able to do that. Okay, that's what we did earlier. Today, okay, we're going to take the sine of, well, now it's an unknown angle, but we're going to know that the answer here is root 3 over 2. So today, our blank, what we're trying to figure out, we're going to try and figure out what angle, when you take the sine of it, gives you root 3 over 2. So pi over 3 is an answer. What else? So yeah, where else is sine positive root 3 over 2? It's 2 pi over 3. 2 pi over 3. Okay, 2 pi over 3. Okay, so the good news, well, I'm going to say here. So the 2 pi over 3, right, because sine in quadrant 2 is also positive, right? We want positive root 3 over 2. We wouldn't want like, 4 pi over 3. That's in quadrant 3, right? And that would be a negative root 3 over 2, which is not quite what we have there. Or you wouldn't want quadrant 4, because which would be 5 pi over 3, because again, negative root 3 over 2. So we only want the positive ones. Now, of course, pi over 3, 2 pi over 3, but really, there's more answers than that, right? So these are the immediate answers on our unit circle, but what could I add to pi over 3 and still be in the same position? What amount can I add to pi over 3 and it'll still be in the same position on our unit circle? Add 2 pi, or I can also subtract 2 pi, right? So there's actually an infinite number of answers that exist here for this particular, kind of question, okay? There's an infinite number of answers here that can fit that kind of question, which is weird because, well, I guess that, yeah.
But it's only one y.
Right, so we have multiple x values that go to that single y value there, yeah. But really, yeah, this is more like, well, anyway, in this case, it's like that, but, well, anyway, I'll show you here. Right, there should only be one y that go with our x's. So, what's that? Yeah. So we'll go over that here in a second, though. So my bigger point, though, is that's the kind of question we're going to be asking, but we're going to be asking in a slightly different way. So to find the inverse of something, right? So let's take that y equals sine of x, okay? To find the inverse of something, what do we do? Switch the, not 1 over, that's reciprocal. We swap the x and y's, right? So we'll say x is equal to sine of y. And then once we do that, what are we supposed to do? Solve for y, right? Ooh, to get sine off of the y there, well, one thing we cannot do is we don't divide by sine. This is not sine times y, it's sine of y. So we have to come up with some sort of inverse function. And the inverse function we do, well, it's going to be, not very creatively, sine inverse. Okay? So we're going to do sine inverse of both sides. Okay? Sine inverse of the left-hand side, sine inverse of the right-hand side. Okay? Sine inverse of sine, well, that's just, they cancel out, right? Because sine inverse of sine, they're inverses of each other, right? So we're left with then y equals the sine inverse of x. Or you might also see this as y equals the, you guys remember from geometry what the other way to write sine inverse is? Arc sine, yeah. Arc sine of x. They're the same thing. Okay, arc sine of x. You use these in geometry. Okay, you use these in geometry, inverse trig functions, back in the day, right? Back however long it was ago for you in geometry. And we'll be using them in a similar sense today too. Okay. Sure. So y equals sine of x is our original function. Okay. We're finding the inverse. So we swap the x's and y's, and we get this. But then to get the inverse, you're supposed to then solve for y. So to get the y by itself here, we got to get rid of this sine. Okay. To cancel out sine, right, we use the sine inverse. Sine inverse. Okay. And that's sine inverse. And we take sine inverse of the left-hand side. So sine inverse of x is sine inverse of x. And sine inverse of sine y is sine inverse of sine y. Okay? The sine inverse of the sine cancels, and we're left with just y. And then sine inverse of x, well, we can't simplify that, so we leave it as sine inverse of x, or arc sine of x. That's the idea. Okay? That's it. Alrighty. Now, so in other words, what we can do there, this problem that we did right here, we could say, okay, sine inverse of root 3 over 2, okay, to answer kind of like write this question in the terms of what we're doing right, you know, with that inverse stuff. We can ask the question, okay, sine inverse of root 3 over 2, okay, we want to know what, you know, angles give us that root 3 over 2, right? So a problem that we should be able to do, like a problem that we come across that we should be able to answer here, okay, is that when we do the sine inverse, you know, of root 3 over 2, we want to be able to answer that, right? We want to know this is something we could see, for example, okay? So let's just say, again, remember that for a normal trig function, your input is a angle and the output is a ratio, okay? But then for inverses, that flip-flops. Now the input is a ratio, the output should be an angle. So we'll just say this is equal to some angle, theta there, okay? And so then if I take sine of both sides, we can see, okay, asking the question, what is the sine inverse of root 3 over 2 is the same as asking the question, sine of what angle gives you root 3 over 2. So these two equations are stating the same thing. They're asking for the same thing. Okay? What angle, when you take the sine of it, gives you root 3 over 2. Okay? Evaluating here, though, evaluating sine inverse of root 3 over 2 means that we have to obey the properties of the inverse sine function. Okay? The inverse sine function. So, okay. So the inverse sine function has some specific properties to it. Okay, so this is again sine inverse of x or arc sine of x if you'd like. Okay. What was the domain of, hang on, let me back up on that. What's the range of sine? Regular old sine of x. What's the range of sine of x? What are the y values that we could, potentially have? What's the range of the y values we could have? Range for sine x. Not infinity, nope. What's the lowest y value you could have for sine? -1. What's the highest? 1, right? Goes between -1 and 1. Sine does, right? Sine goes between -1 and 1. Range, okay? I know, I wrote domain. I'm talking about range now, okay? Remember that because we're inverses now, we have to flip the x's and the y's. So if the range of sine is -1 to 1, the domain of inverse sine will be -1 to 1 as well. Okay? So if the range of sine is -1 to 1, the domain of sine will also be -1 to 1 as well. Kind of, yeah, kind of. It reflected over the line y equals x is what we actually are doing, but yes. Okay? The range, okay. The range, though, well, there's going to be a problem here because I'll show you up. Well, I don't want to show you on the board here. I'll do it over here in this little space. So let me hold off on what the range is going to be in just a second, for just a second here, because I'll just do it up here in this little space. The graph of the sine of x, okay, a little mini graph here, right? It looks like this, right? And it keeps going, so on and so forth, in both directions, right? Imagine taking this graph and reflecting it over the line y equals x. Okay, it's going to look like this. Oh goodness, I hope I do this right. Okay, like that, right? Okay. Is this a function? No. Okay. And since we typically want to deal with functions, okay, or we're talking about arc sine, the inverse sine, as a function here, we need to limit our range, okay? We need to limit our range. The domain will still be from -1 to 1. We want to cover all of our possible x values there, okay? But we're going to limit our range, okay? And the way we're going to limit the range, okay, is to say that we're going to go from -pi/2 to pi/2. Okay? Bless you, bless you, bless you. So we only will, the only answers that we should have here when it comes to evaluating something like this, if we're trying to evaluate inverse sine of √3/2, the only answers that we should have should fit between -pi/2 and pi/2. Okay? So with that being said, here, what angle theta, we kind of did the work up here, right? Do both of these angles fit within our range here from -pi/2 to pi/2? Do both of these answers fit? 2pi/3 is in quadrant 2, right? But -pi/2 to pi/2, that's only quadrant kind of 4 and quadrant 1. Okay, so 2pi/3 doesn't fit anymore. It's just pi/3. So in other words, the answer here is just pi/3. Okay? The answer here is just going to be pi/3. Because we have to limit our range in order to talk about inverse sine as a function. Okay, we don't want to have one input, the ratio here √3/2, going to more than one y value. We want to keep it a function. Okay, when we're talking about just evaluating inverse trig functions. Okay, so let's try another one here as an example. Let's try sine inverse of √2/2. Okay. Sine inverse of √2/2. So in other words, sine of what gives you √2? Oh, Ben, question? Absolutely, absolutely. So you've done this in the past then, and you've used your triangles to do it? Yeah. All right. So let's do that. So Ben says here, let's use our triangles to do it, right? So yeah. If we draw our special right triangles here, so let's see, I'm going to put mine up on the, well, no, I'll show it here because, again, just for the video and stuff like that. If we draw our special right triangles, they can be very helpful here. Okay, so let's see here. I'll do the pi over 4, and we'll say, what is that? I think I have it as root 2, and 2 there. And then we'll do the 30, 60, 90 as well. And pi over 6, pi over 3. There we go. Okay. It does make things a little bit easier here. So Ben, how can we use these special right triangles to figure out what this answer is going to be? Or how would you do that here? What are you looking at?
Just find root 2 to say it's pi over 4.
Okay, yeah, so if you look here, right, we're trying to figure out sine of what angle gives us root 2 over 2. So obviously this triangle right here, right, can't help us find that because there's no way to get a root 2 over 2 in this triangle. But here we can. If we do pi over 4, for example, sine of pi over 4 is root 2 opposite over hypotenuse 2, root 2 over 2. And so that means then sine inverse of root 2 over 2 will be pi over 4. I think it has something to do with kind of like building communication across schools to like make every school better by talking to other students, I guess so. I don't know. We'll find out. Let us know how it goes, guys. We'll see you. Have fun. All right. So yeah, that's how we can use those special right triangles. Let's take a look at this previous one. Right? Sine inverse of root 3 over 2. Root 3 over 2, okay, so again, sine, we want to do sine of what angle gives us root 3 over 2? Well, there it is, pi over 3, right? Sine of pi over 3 is opposite over hypotenuse, root 3 over 2. And so there's your answer right there, which is pi over 3, okay? So the pi over 3 is the angle, sorry, there's it. Sine of pi over 3 is the angle that gives you that root 3 over 2 there. So, okay? Let's do 2 more here real quick. What's sine inverse of negative root 2 over 2 going to be then? Yeah. So this is a little bit trickier, right? Negative root 2 over 2, well, looking at our triangles, right, a positive root 2 over 2 we can get from using that pi over 4. But we need to be negative root 2 over 2. Well, since we know the ratio is root 2 over 2, that means pi over 4 is going to be like our reference angle here. So we can use that pi over 4. Well, let's see. So we could say like, well, what quadrant do we need to be in here, I guess, is my question, right? We could go to quadrant 3, right? Sine is negative in quadrant 3, or in quadrant what else? 4, okay? If we look down here at our range, right, quadrant 3 is excluded, right? We can't do quadrant 3. Again, negative pi over 2 to pi over 2, that is, if you think about the unit circle here, that's from like negative pi over 2 to pi over 2 is like these 2 sections of the unit circle. So we're going to have to be down in here in quadrant 4. So the pi over 4 angle here in quadrant 4, you could say is, well, you could say it's 7 pi over 4, right? But 7 pi over 4, again, is not in here. We're going to have to just do negative pi over 4, okay? Negative pi over 4 is in that range there, so we'll say negative pi over 4 is our answer, okay? Negative pi over 4 is our answer there. Yes, quadrant 4. Because again, because of our range being between negative pi over 2 and pi over 2, we have to come up with a pi over 4 reference angle, or pi over 4 angle, right? That's between these 2 numbers.
But wouldn't it be like the
7 pi over 4, right. But 7 pi over 4 is not in our range here. Our answers, when we're doing inverse sine, have to fit within our range of negative pi over 2 to pi over 2. So we basically, essentially, when it comes to sine, okay, the easiest way to kind of think about this is that if you're taking the sine inverse of a positive ratio It's just the normal kind of positive angle that you'd get, right? So sine inverse of root 3 over 2 gives you positive pi over 3. Sine inverse of root 2 over 2 gives you positive pi over 4. But then when you take the sine inverse of a negative angle, you just want to treat it like you're doing the positive one, okay? So do sine inverse of root 2 over 2, right? But then just make your answer negative, and that'll fix what your answer is supposed to be there, okay? And again, it all has to do with how the range is defined there. We have to pick it between negative pi over 2 and pi over 2. So the pi over 4 angle that's in the fourth quadrant, right, that's in this range would be negative pi over 4. So that's the idea there. Okay? We'll get some more practice here with it, though. We'll do some more. Okay? All right. Inverse cosine. Okay. Inverse cosine, which again looks like this or this. Okay. Its domain is also negative 1 to 1, just like sine, because again, cosine's the original graph of cosine. Its y values go from negative 1 to 1, so then the inverse would have the x values going from negative 1 to 1. Okay. Its range, though, is from 0 to pi. Okay, 0 to pi. And then inverse tangent inverse tangent function, which again, tan inverse or arctan. Okay, and be careful here, right? That when you have tan negative 1x, you might think, oh, that means 1 over tangent of x, right? It's not, though. If you want to do 1 over tangent of x, you put parentheses around the entire tangent x and then have it to the negative 1 power. Okay, so this means tangent inverse, so be careful with that, because that can look like just do the reciprocal of tangent, which it's not. Okay, it's the inverse of tangent. Sorry. Okay, domain for this. Well, since the range of tangent, the range of normal tangent is negative infinity to infinity, the domain here will also be negative infinity to infinity. Okay, and then the range, okay, will be like sine, it'll be negative pi over 2 to pi over 2. Bless you.
So why is cosine different?
Cosine is different because of no, it's okay. So no, it's a good question. So sine and tangent, so they both, how do I describe this? Like basically, let me maybe try and draw it this way. It might be helpful. Okay. We include quadrants 1 and quadrant 4 in the range of our sine and tangent because in quadrants 1, and in both cases, right, both sine and tangent are positive, and in quadrant 4, sine and tangent are both negative. So we cover the entire range of possibilities if we do just from negative pi over 2 to pi over 2, this side. Same thing here. If we go from negative pi over 2 to pi over 2, we cover all of the possible positive and negative angles there. For cosine, though, cosine's positive in the fourth quadrant. If you remember, all students take calculus, right? So the C there, that's positive. So if we did negative pi over 2 to pi over 2, we would like be doubling up. We would have positive angles here and positive angles here. Positive ratios here and positive ratios here. So in order to then kind of allow for the negative ones, we go from 0 to pi. Cosine is negative in quadrant 2, so that allows us to cover positive in the quadrant 1 and then also negative in the quadrant 2. That's the difference, and that's why we have to do it differently there, because of the way cosine is. Okay, where its signs are. Okay, so let's do a few more examples here. Maybe I think it might be helpful if we do a few more examples. Okay, before we then jump too far here. Yeah. Excuse me. Okay, So again, just gonna throw some numbers out here. Let's do like, I don't know, arctangent of 1. Okay, arctangent of 1. So arctangent of 1, in other words, tangent of what gives us 1? Well, we can go back up to our little triangles here, right? Tangent, remember, is opposite over adjacent. So at what angle here, if we do opposite over adjacent, are we going to get 1? Tangent of what angle here is going to give us 1? Pi over 4. Yeah, pi over 4, right? Tangent pi over 4. Opposite is root 2 over the adjacent leg, root 2, so we get 1 there. Okay? So, arctangent of 1 is pi over 4. Okay? What would arctangent of negative 1 be? Negative pi over 4. Okay? So again, for sine and tangent, if you're evaluating a negative ratio, okay, so if you're doing arctangent of a negative number, evaluate it just like you're evaluating the positive one, and then just make your answer negative. That's it. Okay? So the answer will be the same as the positive version, just it'll be negative instead. Okay? Let's try another one here. How about let's do arcsine of 1. Okay, now this one's a little bit different. Arcsine of 1. So sine of what angle gives us a positive 1? This one's not, you can't use your special right triangles for this one. But it's on the unit circle. So sine of what angle gives us 1? Pi over 2. There you go. Good job. That's right. Okay. What about arcsine of 0? What would that be? Or in other words, sine of what gives us 0? 0, right? 0. Okay, right? Let's do some cosines. I haven't done any cosines. Let's do arc cosine of, I don't know, root 3 over 2. Okay? What is that? So cosine of what gives us root 3 over 2? Pi over 6. Pi over 6. Okay? But then, and here's where it's a little bit different, right? So arc cosine of negative root 3 over 2, okay? So for cosine, because of where it's positive and negative in the quadrants, okay, we cannot just say, since we just did positive root 3 over 2, we cannot just say here the answer is negative pi over 6. Negative pi over 6 is not in the range of cosine. You see, right? It goes from 0 to pi. So in other words, we have to come up with a quadrant 2 angle whose reference angle is pi over 6. So what quadrant 2 angle has a reference angle of pi over 6? 5 pi over 6. So the answer here is 5 pi over 6. Okay? So that's the idea there. Okay? So is that making some sense here? Because we still have some other stuff I got to cover too. I'll do one more here, just as arcsine of 2. So in other words, the question is sine of what angle gives us 2? What would the answer be for that? Sine of what angle gives us 2? That's right. There is no answer. What's that? Oh, thanks, Jenna. I hope that's a good thing. I guess so, right? A favorite teacher. I don't know. That's true. No answer is the answer because what's the highest value that sine can be? 1. So there is no way to take sine of an angle and get 2, right? So the answer is there is no answer. Okay? All right. We're not done. But that was the hardest part. That was the hardest part for sure. Okay? I don't even know how I want to title this. I'll just maybe something like combining inverse trig with trig. I think we'll be able to fit it. I hope so. Although I know you write larger than I do, I think, right? So, but
I really do.
yeah, all right. We'll see. All right. So I'm going to do some obvious ones first, and hopefully it'll be obvious to you too, right? So for example, if I do the arc cosine of the cosine of x, what does that result in? So if I do arc cosine of the cosine of x, what does that equal? X, right? It just simplifies to x because they're inverses. They cancel each other out and simplifies just to x. It's like taking e to the natural log of x, or natural log of e to the x, right? Or the square root of x, well, the cube root of x cubed, that kind of thing, right? They kind of cancel each other out. You do the inverse to the normal function, and they cancel out, right? If I do arc sine of the sine of x, what does that equal? Not a trick question. X, yep. And then what about arc tangent of the tangent of x? It's x, right? Okay. So the idea of these things are inverses, okay? But that's too easy for us, right? What about arc cosine, tangent of the arc, not 2/2, 2/3. Okay? Tangent of the arc cosine of 2/3. Okay? Does tangent, or arc tangent and arc cosine, are they inverses of each other? No, right? So they don't cancel each other out. But we can still evaluate this, believe it or not. We can still evaluate this thing. And let me show you how we can do that. Okay? What we're going to do is take this piece by piece. So in other words, we're going to figure out, we're going to use this arc cosine of 2/3, and then we'll take tangent of that answer. Okay? Yeah, it's 2/3. Sorry. I keep writing over it, and it keeps looking worse, but, you know. So, what's that? What 2/3 is? Like 2/3 you're saying? Not quite, because if this was cosine of arc cosine, then yes, the answer would be just 2/3. But this is tangent of arc cosine. They're not exact inverses of each other. That's okay. So what we're going to do here is take this arc cosine of 2/3, and because it's arc cosine, we know that the input is a ratio and the output should be an angle. So I'm just going to set it equal to theta. So in other words, I could, bless you, just as easily say here that cosine of theta is equal to 2/3, right? Asking this is the same as asking this. Arc cosine of 2/3 equals what? Is the same thing as cosine of what equals 2/3. This, remember that our fundamental definition of cosine is that cosine relates an angle with the adjacent leg of a right triangle with its hypotenuse. So what we're going to do is draw a little right triangle here. Okay? Put theta in for one of those acute angles, and then use cosine to label it. So cosine of this angle theta should be 2, the adjacent leg, and then 3 should be the hypotenuse. Okay?
Wait, could you go over that again?
Yeah, so I'm taking this piece right here and saying that that is just going to be some angle theta. Okay? So I say, okay, let's just set it equal to theta. Just for, like, we're going to work on this piece first, and then we'll do tangent here. Okay? Let's just work on this piece. If this is true, that means cosine of theta is 2/3. Right? If I take cosine of both sides here, cosine of arc cosine will cancel, and then cosine of theta is just going to be cosine of theta. So I get this. So far, so good from here to here?
Yeah.
Okay? So this relates just to this, right? We have a right triangle, right? We can create a little right triangle from that information. Nope. It's all one step here, kind of thing. Now, remember that I said that we said arc cosine theta of 2/3 is. We said if arc cosine of 2/3 is theta here. So in other words, this is really just trying to find the tangent of theta. Right? I said we're going to make arc cosine of 2/3 be theta. So I can replace this arc cosine 2/3 with this theta that I'm talking about right here. Okay? To find the tangent of theta, well, tangent is opposite. Ooh, I need to figure out the opposite, but can I figure out the opposite leg here? Using what? Pythagorean theorem, right? It'll be 2 squared plus b squared equals 3 squared. So I get 4 plus b squared equals 9. So I get b squared equals 5, or b equals root 5. Yes, we could say plus or minus, root 5 here, but we're talking about a triangle, so we're going to leave it just positive root 5 there. Okay. And so then what is tangent of theta going to be here? Opposite, root 5. I wrote 2 and I said 5. That's weird. All right. Root 5 over adjacent leg 2. So our final answer there is root 5 over 2. Okay. So we actually don't have to figure out what theta is. We can kind of bypass that and then still get our answer here. Okay. Let's try another one here. Let's do sine of the arc cosine of 1/2. Again, these are not direct inverses of each other, right? Sine and arc cosine, they don't cancel each other out. But we can still do just like we did before here. We can take that arc cosine of 1/2, set it equal to theta. Okay, we can know the output for an inverse trig is going to be an angle here, which means then equivalently I could say that cosine of theta is 1/2. Right, same idea. Set up our triangle here. Put the theta in. Cosine is adjacent over hypotenuse. Okay. We should recognize this triangle maybe. What's this third side going to be? Root 3, right? It's a 30, 60, 90 right triangle there. You can also find it by using Pythagorean theorem. Okay. So then if arc cosine of 1/2 is theta, right, I can replace this arc cosine 1/2 with theta, so we'll just do sine of theta. What is sine of theta according to our right triangle here? Root 3 over 2. Okay. In this case, we can actually figure out what theta is, right? Arc cosine of 1/2, right? Cosine of what angle gives us 1/2? What's that going to be? It's going to be pi over 3, right? And so then sine of pi over 3 gives us that root 3 over 2. So you also could have figured out the actual angle there because it was one of our, unit circle angles. Okay? All right, we have one last application. This will be easy, though. This is just a review from geometry. Okay? And that is solving for angles. Okay? Solving for angles in a right triangle. Okay? And I think I'll just do one here because I really think you guys will get the idea after just one. Okay? I'll let you guys get started on the assignment after this. All right, let's say we've got a 3 here and a 5 here and theta here. Let's say we want to find theta. Okay. Well, how can we relate theta with the information that we're given here in this right triangle? We have the opposite side to angle theta, or the opposite leg, and we also have the hypotenuse. So what trig ratio, right, relates opposite leg and hypotenuse? Sine does. And so we'll say sine of theta equals 3 over 5. And then to get theta by itself here, we'll do sine inverse of both sides. Okay. Are you responsible for knowing what the sine inverse of 3/5 is? It's not on our unit circle, right? 3/5 is not a ratio that we have on our unit circle, and so no, you are not responsible for knowing that. So then how do we figure it out? Calculator. Okay. In this context, what mode do you think we should be in? You can use radians if you want to, or degrees. It's really your choice, okay? I would say degrees for triangles. I don't know, for me that just seems more, like typical, I guess. But if you want to do radians, I guess that's okay. I think degrees though. So I'm going to change my mode here to degrees. Okay? And then to do sine inverse, you do second sine, and then sine, and then 3/5. And then there's your answer. 36.9 degrees, we'll say. I'll just round to 36.9 degrees. Okay? That's from geometry, though, right? That's hopefully just review from geometry there. All right. I think I've talked enough. I've done enough damage. So what we'll do is get you guys a chance to try and kind of struggle with this on your own, and I'll make myself, of course, I'll walk around the room and help some too. Okay. Your assignment, let me get that here. And I'll also post the review for the test as well, so you can look at that. Let's see here. Page 347 in the book. Numbers 5 to 15, 27 to 31, 55 to 59, 71, 73, and those are odds only, and then also 106 as well. Okay. So 5 to 15, 27 to 31, 55 to 59, 71, 73, and then 106. Okay. And of course, I'll post the test with you too.
Do you think this is the homework for the tangent graphs?
Oh, yes. I'll post that here. Sorry again?
Sorry.
Yeah, you ready? Okay. Jenna asked for the homework answers, so I'm going to post these up here. If you want to come and take a look at them at the front of the board too, it's not going to really quite work there. Anyway.
I'm doing it this way to check.
Yeah. You want to turn it around for yourself or something like that? It's fine.
Phone and video. That was the other ones, right? Oh no, that was a tangent one too.
Yes, they're all. There's some there's a tangent on the back. I think.